You have, let's say you have a mountain that slopes down here. Alright? Here's a mountain. If you have something, let's say you have a rock right here. Alright? Now, this rock has the potential energy to fall. Has the potential to fall, right? To create energy. So this is considered potential energy. The rock has the potential energy right there. It's not moving, but it has the potential to become energy. To become kinetic energy. Kinetic energy is motion. So here we are. You have potential energy within this rock. So once it starts rolling down, this potential energy within the rock, which equals I, initial, this potential energy within this rock, right here, has the potential to become kinetic energy, motion. Kinetic energy equals motion. Movement. Kinetic energy equals movement. Motion. So, as long as you have some potential energy existing, you have the ability to create kinetic energy. Now, as it falls down here, as this rock falls, it rolls, the potential energy turns into kinetic energy. And at the end result, as it levels off, the energy is equally distributed and it becomes a 0 point. It is, okay? The sum equals 0. What I mean by that is this. The potential energy here, PE, this is the initial energy, the potential energy. And the kinetic energy is like this. It's described as having potential energy, initial, plus the kinetic energy. So this state right here and this state equals this. Potential energy, initial, the beginning, plus potential energy. So you have the potential energy here. This is represented here. So potential energy, the initial potential energy, plus kinetic energy, the initial kinetic energy, initial, and this represents this right here, and it's moving. So you have the potential energy here, you have the kinetic energy here. this as a whole equals here. When it levels off, when the rock levels off and moves and all that around here, this part right here, because these two are together, combined. This is potential energy here, and your kinetic energy as it moves. This as a whole, this and this as a whole, is combined. That equals this part right here. This. And then this equals this. The final. And this rock, this is a rock. Alright, as it comes down, it levels off. It bounces off, so whatever the result here is, the end result is, the final result is the sum of these two combined. And this part equals potential energy final plus kinetic energy. Let me put it over here. Here, I'm bringing this right here. So you have potential energy right here. Your initial potential energy plus your initial kinetic energy, because this is this right here in action. That's motion. So your potential energy turning into kinetic energy. Your initial kinetic energy. This is combined. This equals the end result, the final result. So here you have your initial potential energy at rest. And that's potential energy right here. This part right here. This part equals potential energy at rest. Now, your kinetic energy, your initial kinetic energy is movement right here. So this plus this equals this, the end result, the final result, which equals potential energy, final result, final, plus kinetic energy, final. So this cancels out with this. And this is the final result right here. All the energy is equally distributed right here. Everything that occurred within the potential initial state and the kinetic state, the motion, these two states, represented by this, by here and here, equals the final state, which is the energy is equally distributed here. As it rolls and levels off, it's equally distributed. That's just the way it works. Now, what does this mean? Just because it's equal, just because this equals this, what does that really mean? Sum equals 0, conserved. However, We still don't see the whole picture though.